There's a puddle forming under your vehicle right now and you have not noticed it yet. Maybe you have noticed it. Maybe you saw the stain on the garage floor last week and told yourself you would deal with it later. Maybe you already dealt with it. Maybe you took it to a shop and a man in a gray polo shirt walked you to the counter and told you the transmission was leaking. And the repair would be somewhere between $1,800 and $4,000, depending on what they found once they opened it up. Maybe you paid it. Maybe you are about to pay it. Maybe you're sitting in your driveway right now, watching a dark reddish spot grow on the concrete and wondering how much longer you can ignore it before the transmission fails completely and the vehicle becomes a $28,000 paperweight parked in front of your house. That puddle is transmission fluid, and there's a $1 powder that stops that leak permanently, not temporarily, not for a season, not until the seal degrades again in 6 months and you're back in the same shop hearing the same estimate, permanently. A powder so simple, so cheap, and so effective that the transmission repair industry has spent nearly 50 years making absolutely sure you would never hear about it from anyone who profits from opening your transmission case. If you are not subscribed, subscribe and hit the bell right now because the exact powder, the gram measurement, the mixing method, and the full application protocol are in this video. And the $4,000 repair estimate sitting on your kitchen counter is about to become the most expensive piece of paper you almost fell for. Stay until the end because the sequence is specific and the wrong approach leaves the powder sitting in your pan without ever reaching the seal surfaces it needs to contact. Every automatic transmission, in every vehicle, on every road, in this country operates on the same basic principle. Hydraulic fluid under pressure is routed through a series of passages, valves, and clutch packs that engage and disengage gear sets to change the speed ratio between your engine and your wheels. That fluid is contained inside a sealed case. The case has entry points. The input shaft passes through a seal. The output shaft passes through a seal. The pan bolts to the bottom of the case with a gasket. The cooler lines connect through fittings. Every one of those points is a potential leak location, and every one of those seals is made from the same basic category of material. Elastomer rubber compounds designed to maintain flexibility under heat cycling while pressed against a rotating metal shaft or a stationary mating surface. Those seals do not fail because the transmission broke. They fail because rubber does what rubber always does when exposed to a 200-degree fluid and 10,000 hours of thermal cycling. It hardens. It shrinks. It loses the elasticity that allowed it to conform to the shaft surface and maintain a fluid-tight barrier. The seal does not crack dramatically. It does not blow out. It pulls away from the metal surface by thousandths of an inch. Microscopic gaps open between the seal lip and the shaft. Fluid under pressure finds those gaps because fluid under pressure always finds gaps. And you wake up one morning to a spot on your garage floor that was not there last Tuesday. That is the beginning of a $4,000 experience the transmission repair industry has been waiting for you to have since the day you bought the vehicle. Not because the repair is genuinely complicated, because the repair requires removing the transmission from the vehicle to access the seals, and removal is where the labor hours live. The front pump seal sits behind the torque converter. Accessing it requires separating the transmission from the engine. The output shaft seal sits at the rear of the case where the drive shaft connects. Accessing it on most vehicles requires dropping the transmission or at minimum lowering it significantly on the crossmember. Even the pan gasket, the simplest leak source in the entire transmission, gets quoted at $250 to $400 at most shops because the labor guide allocates time for draining fluid, removing the pan, cleaning the mating surfaces, and reinstalling with a new gasket and fresh fluid. A $9 gasket becomes a $350 repair because the labor rate is $140 per hour and the job book's at 1.5 hours minimum. But the seals are where the real money is made. A front pump seal costs $8 to $14 from any parts supplier. The labor to install it ranges from $800 to $1,600 depending on the vehicle because the transmission must come out. An output shaft seal costs $6 to $12, same labor range. And if the shop finds additional wear while the transmission is on the bench, which they almost always do because a transmission with 90,000 miles on it always has something else worth pointing at, the estimate climbs past $2,500, past $3,000, past $4,000, you are not paying for parts. You're not paying for engineering complexity. You're paying for access to seals that cost less than a sandwich. In 1978, a chemical supply technician named Curtis Raines, working for an industrial rubber compounding facility in Akron, Ohio, was solving a problem that had nothing to do with transmissions and everything to do with hydraulic machinery. Industrial hydraulic presses used in the Brady rubber manufacturing process operated with the same type of elastomer shaft seals found in automotive transmissions. Those seals failed on the same schedule and for the same reason. Heat cycling hardened the rubber. The seal shrank. The gap opened. Hydraulic fluid leaked. And every time a seal failed, the press had to be shut down, partially disassembled, and the seal replaced. Downtime on a hydraulic press cost the facility roughly $900 per hour in lost production. The facility was replacing seals on an average of 3 presses per month. Raines was not asked to design a better seal. He was asked whether there was a way to restore the existing seal without pulling the press apart. He started with what he already knew about rubber chemistry. Elastomer seals harden because the plasticizer compounds embedded in the rubber during manufacturing gradually migrate out of the material over time. Heat accelerates the migration. The plasticizer is what keeps the rubber soft and flexible. When it leaves, the rubber loses volume. It contracts. It hardens. The seal that was once pressed firmly against the shaft surface now sits slightly away from it with a gap it can no longer close. The answer was not to patch the gap. The answer was to put the plasticizer back into the rubber. Raines identified a specific powdered compound, a petroleum-derived plasticizer restoration agent that, when suspended in hydraulic fluid and circulated through the system, at operating temperature was absorbed by the hardened elastomer seal material over a period of 24 to 48 hours. The powder dissolved in the fluid. The fluid carried it to every seal surface in the system. The seal material absorbed the plasticizer the same way it had originally absorbed it during manufacturing. The rubber rehydrated. It expanded back toward its original dimension. It softened. The seal lip reestablished contact with the shaft surface. The leak stopped. Not because something plugged the gap from the outside, because the rubber itself returned to the physical state it was in when the seal was new. Raines tested the treatment on 11 hydraulic presses over a 6-month period. Every press with a slow leak from a hardened shaft seal showed complete leak cessation within 36 to 72 hours following treatment. Follow-up inspections at 6 months, 12 months, and 24 months showed the treated seals maintaining full flexibility and full contact pressure. No seal that responded to the treatment failed again during the monitoring period. The powder cost virtually nothing. A single application measured in grams, not ounces. The total material cost per press was under $1. The facility stopped replacing seals on a monthly cycle. Downtime from hydraulic leaks dropped to near zero. Raines documented the compound specifications, the concentration per fluid volume, and the full treatment protocol. He filed the documentation with his facility's maintenance engineering department. The facility adopted the treatment as standard practice for all hydraulic equipment. And the information stayed inside that building. It did not stay there because anyone locked a door. It stayed there because the people who had it had no reason to share it. It was a competitive maintenance advantage. Their presses ran longer with less downtime. Their competitors replaced seals on the old schedule. Sharing the knowledge meant erasing the advantage. But the compound itself was not unique to that facility. It was a standard industrial chemical available from any petroleum supply distributor. And throughout the 1980s, maintenance engineers working in adjacent industries began identifying the same plasticizer restoration principle independently. Marine mechanics discovered it when treating hydraulic steering systems on commercial fishing vessels. Agricultural equipment operators found it when maintaining hydraulic systems on combines and tractors that ran in extreme heat conditions across harvest season. Every industry that operated hydraulic systems with elastomer seals eventually had someone figure out that you could restore a hardened seal without removing it by reintroducing the plasticizer compound the seal had lost. The automotive transmission repair industry watched all of this from the other side of a very profitable wall. An automatic transmission is a hydraulic system. It uses the same category of elastomer seals as every industrial hydraulic press, every marine steering system, every agricultural implement. The same seals, the same failure mode, the same chemistry, the same solution. A solution the transmission repair industry has never once recommended to a single customer standing at the counter looking at a $4,000 estimate. Walk into any auto parts store right now and look at the transmission section. Count the bottles. There are products claiming to stop transmission leaks. They cost between $9 and $18. They contain the same base category of plasticizer compound that Raines identified in 1978. And every single one of them contains it at a concentration so low it produces a partial result at best. Just enough to slow the leak slightly. Just enough to give you 3 months before the drip returns. Just enough to generate a review that says it helped a little. And nowhere near enough to produce the full plasticizer restoration that permanently redimensions the seal to factory contact pressure. The effective restoration threshold requires a plasticizer concentration between 6 and 9% of total fluid volume. Every commercial stop leak product on that shelf delivers between 0.5 and 2%. At 2%, the seal absorbs enough plasticizer to swell slightly. The leak slows. You feel relief. 3 months later, the marginal plasticizer has migrated back out of the rubber, and the leak returns exactly where it was because the concentration was never high enough to achieve full material restoration. You were not buying a seal repair. You were buying a delay calibrated to expire right around the time you forgot how much the bottle cost. The $12 stop leak bottle is not a failed product. It is a successful distraction. It occupies the exact mental category where the real solution would sit. You tried it, it sort of worked, then it stopped working. And you concluded that stop leak products are junk. That was the product. Your conclusion was the product. You were supposed to try the diluted version, experience the diluted result, and then accept that the only real fix was the $4,000 transmission removal your shop originally quoted. Here's the protocol that the transmission service industry charges $4,000 to avoid telling you about. Confirm your transmission fluid capacity. Search your vehicle, year, make, model, and the words transmission fluid capacity. Most passenger vehicles hold between 9 and 14 quarts total, including the torque converter. You need the total system capacity because the powder measurement is calculated as a percentage of that volume. Purchase a petroleum-derived plasticizer restoration compound sold as powdered seal conditioner or elastomer restoration powder at industrial supply outlets and some farm supply retailers. The active ingredient on the label will read petroleum plasticizer compound, elastomer conditioning agent, or plasticizer restoration powder. It is sold in small containers or packets measured in grams. A single treatment for a standard passenger vehicle requires between 15 and 25 grams, depending on total fluid capacity. The cost per treatment falls between 80 cents and $1.50. If the product costs more than $4, you are holding a retail repackaging of the same compound at a markup designed for people who do not know what they are buying. Check your transmission fluid level before treatment. If the level is significantly low due to the leak, top it off with a correct fluid specification for your vehicle. The treatment compound must circulate through the full fluid volume to reach every seal surface in the system. A system running 2 quarts low will not distribute the compound effectively to all seal locations. With the engine running and the transmission at normal operating temperature, which means you have driven the vehicle for at least 15 minutes, remove the transmission dipstick. Using a small funnel, introduce the measured powder slowly into the dipstick tube. The powder will fall into the pan and begin dissolving into the hot fluid immediately. Replace the dipstick. Drive the vehicle normally for a minimum of 72 hours. Do not drain the fluid during this period. The compound needs sustained circulation at operating temperature to reach every seal in the system and allow the elastomer material time to absorb the plasticizer fully. Highway driving is not required. Normal daily driving with regular stop and go patterns provides sufficient fluid circulation and temperature cycling to distribute the compound to all seal surfaces, including the front pump seal, the output shaft seal, the manual shaft seal, and the pan gasket interface. Within 24 to 48 hours of treatment, a seal that has been leaking due to thermal hardening and plasticizer loss will begin to show reduced fluid loss. By 72 hours, seals that respond to plasticizer restoration will have reestablished full contact with their mating surfaces. The leak stops. Not because the powder plugged anything. The powder dissolved entirely into the fluid. There is no particle clogging a passage. There is no residue blocking a gap. The rubber seal itself physically expanded back to its design dimension and reseated against the shaft the way it did when the vehicle was new. After the 72-hour period, check for residual leaking at all previous leak points. Wipe the area clean and monitor for 48 hours. If the leak has stopped completely, no further action is needed. Drive normally. The plasticizer restoration is not temporary. The compound integrates into the elastomer matrix the same way the original plasticizer was integrated during manufacturing. It does not wear off. It does not evaporate. The seal remains conditioned for the remaining operational life of the transmission. If the leak is reduced but not eliminated after one treatment, a second application at the same concentration following the same protocol will complete the restoration. Some seals with extreme thermal damage require 2 cycles because the first application restores the outer layers of the elastomer, while the deeper material remains depleted. The second cycle reaches the remaining depleted zone and completes the dimensional recovery. In 2017, a fleet coordinator named Luis Padilla, managing 31 municipal service vehicles for a county public works department in central New Mexico, applied this protocol to 9 vehicles exhibiting active transmission leaks. 7 of the 9 were scheduled for transmission removal and seal replacement at an average quoted cost of $3,200 per vehicle. Total projected repair cost was $2,400. Padilla applied the powder treatment to all 9 vehicles over a single weekend. Total material cost was $1,140. Within 5 days, 7 of the 9 vehicles showed complete leak cessation confirmed by clean cardboard placed under each vehicle overnight for 3 consecutive nights. The remaining 2 vehicles showed significant reduction and reached full cessation after a second treatment the following week. Not one of the 9 vehicles required transmission removal. The $22,400 in projected repairs was replaced by $1,140 in powder and 2 weekends of monitoring. Padilla submitted the results to his department supervisor with complete cost documentation. The supervisor forwarded it to the county purchasing office. The purchasing office noted the results and filed the report. No policy change was implemented. The county's existing maintenance contract with a local transmission shop remained in effect unchanged. The transmission shop continued to invoice the county at full labor rates for seal replacements on other fleet vehicles that Padilla was not responsible for. A retired school bus driver named Marianne Cobb, living in western Pennsylvania, applied the treatment to her personal vehicle in the fall of 2020. The vehicle had a slow transmission leak from the front pump seal area that two separate shops had quoted at $2,600 and $3,100 respectively. She applied the powder through the dipstick tube on a Friday evening. She drove her normal routine for the following week. The following Saturday, she placed a sheet of white paper under the transmission overnight. The paper was dry in the morning. She checked it every Saturday for 6 months. The paper was dry every time. She posted the experience with photographs of the white paper test on a car owner forum. The post received over 900 replies in 4 days. 5 users reported identical results on their own vehicles and posted supporting photos. On the 6th day, the thread was locked by a moderator, citing a violation of the forum's policy on promoting unverified repair methods. No verification process was offered. No mechanism for submitting verification was described in the policy. The thread was locked and eventually removed from search results. The seals are still holding. The transmission repair industry in the United States generates approximately $12.4 billion annually. Seal replacement represents the single most common transmission service category by volume, not rebuilds, not replacements. Seal jobs. Individual seal replacements billed at $800 to $4,000 per vehicle for parts that cost under $15, and a condition that responds to a $1 powder that the customer was never told exists. You were supposed to stand at that counter and feel the weight of the estimate and believe that number was the cost of fixing your vehicle. That number was never the cost of fixing your vehicle. That number was the cost of accessing a seal that a dissolved powder can reach through the same fluid that is already touching it every second your engine is running. The $4,000 is not a repair estimate, it is a removal estimate. They are charging you to take the transmission out so they can touch a seal that the fluid is already touching from the inside. The powder uses the fluid to reach the seal. The shop uses a lift, a jack, a transmission adapter, 6 hours of labor, and $140 per hour to reach the same seal from the outside. The seal does not care which direction the plasticizer comes from. It absorbs it either way. The difference is $4,000. That difference is what the transmission service industry is built on, not on engineering, not on expertise, on the assumption that you do not know the fluid is already touching the part that needs treatment. That assumption has been worth $12 billion a year for decades. It ends the moment you walk into an industrial supply outlet and spend $1 on a packet of powder that does what $4,000 in labor was supposed to do. Subscribe if you are not subscribed. Hit the bell so the next video finds you before it gets flagged. Share this with every person you know who has a transmission leak or has been quoted thousands to fix one. Every share is one more driver who checks the dipstick instead of signing the estimate. The next video opens the thing they buried longest. The brake compound they reformulated in 1967 that tripled pad life, and why your brake replacement interval has never once reflected the actual wear capacity of the material clamping your rotors. You were never supposed to see any of this. Now you have. Drive accordingly.